Hi everyone, Mr. Chaffee here for today's lesson on slope and writing linear equations. We're going to review how we can calculate slope, as well as how we can apply our slope into the various forms of equations which we've encountered throughout the year. First, let's start off going over some vocab terms in order to help refamiliarize ourselves with some important concepts for today's lesson. Starting off, we've got our slope itself, which is the rate of change or measure of steepness of a line. Then we have a horizontal line, which has a slope of 0, a vertical line, which has a slope that is undefined, an x-intercept, which is the point where the function crosses the x-axis, and last, the y-intercept, which is the point where the function crosses the y-axis. Then we have our helpful slope man over here, Mr. Slope Guy, to help remind us of some of these key terms just by looking at his facial expression. So we can see with his left eye, he's got a positive sign here and a positive slope for his eyebrow. It's sloping up and to the right. Likewise, his right eye is a negative sign, sloping down to the right, representing a negative slope here. Then for his nose, we have this vertical line and a U underneath it to remind us that the vertical lines are undefined. And for his mouth, he's got a flat horizontal line here with some zeros as dimples to remind us that a slope of 0 happens whenever we encounter that horizontal line. Now let's talk about how we can actually calculate our slope. So if we have our 2 points, x sub 1, y sub 1, and x sub 2, y sub 2, where x sub 1 does not equal x sub 2, we can say that these are 2 distinct, unique points from one another. Then we can calculate our slope, which we commonly call m, and we can set that equal to our rise over our run, which is simply just the change of height, how we change from our vertical distance from our second y point to our first y point, and the change of our horizontal distance between our second x point and our first x point. So once we divide those two by one another, we get the slope for that line. Now let's take a look at a couple of examples of actually finding our slope with some lines from some graphs. So we've got this first example here where we're given this line and we're going to need to find 2 points off of our line in order to calculate our slope. So I can see that we have a point of 0, 1, as well as a point of 1, 2 here on this graph. So that's this point and this point. And I can say my slope of m is equal to my y2 minus y1 over x2 minus x1. Now I can just plug in all of my terms here. So we had my second y point was 2, my first one was 1, and then we had 1 and 0 for the bottom, which simplifies down into 2 over 1 over 1, which will give us 1 for our slope here. Now let's try out letter B. Let's pick off a couple of more points that are easy to read. That one looks nice and easy to read. So does this one. So my 2 points, we've got -2 and 1, as well as 0, -3. So now if I want to find the slope for this line, I'll take my -3 minus 1 for my numerator, and 0 minus -2 in my denominator, which is going to give me a -4 over a +2, which simplifies down into a -2. So this one has a slope of -2. For letters C and D, try and see if you can pause the video on your own and figure out what these two slopes are for these two graphs. Once you feel pretty confident, you can unpause the video, then we can go over your solutions together. Okay, so for letter C, we can see that we immediately have a horizontal line here, which we know has a slope of 0, but let's just also go ahead and calculate that just to prove it for ourselves. So I'm just going to take 2 points off of this line. So I've got 0, 2, and 2, 2. So now when we calculate our slope, we can say we'll get 2 minus 2 over 2 minus 0, which is 0 over 2, which is equal to 0. So every time we have that horizontal line, our 2 y terms on top are always going to be equivalent to one another, which is going to always result in a 0 here. And 0 divided by anything was going to give us a final answer of 0 for our slope here. So that's why our horizontal lines have those slopes of 0. Now let's try this last example with letter D here. So I can see that's a nice easy point to read. So is this. So we've got the points 0, 1, and 4, 0. So now let's find our slope, we'll take 0 minus 1 all over 4 minus 0, which is going to give us negative 1 over 4. So we have this negative slope, downward sloping, and it's not very steep, so we have this fraction here of negative 1/4. So that looks right to me. Now let's move on and find some slopes without some graphs here. So we are just given the points themselves, but we don't actually need the graph to find the slope. We can just use these points by plugging them into our formula. So we'll have our slope of m, and we're taking our two y points for our numerator, so our 14 minus 8, and then for our denominator, let's have negative 7 minus 10. And the key thing is, whenever we're doing these problems, we want to make sure that we're placing our values in the same order. So I'm starting with this point as my second point. So my y2 comes first when I subtract the 2 points, which means I also need to start with my x2 here to find my denominator. So I need to make sure I have that negative 7 first and not my 10, since I started with my 14. So just make sure you're consistent with these points when you're actually calculating your slope. But other than that, I think it should be pretty straightforward. A lot of you were really good at this in class. So now we'll have 14 minus 8 is 6, and negative 7 minus negative 10 gives us a negative 17. So our slope will get negative 6 over 17. Which is kind of an awkward slope to graph, but at least we don't have to graph this one. Let's try out number 3 together, which is asking us to find the value of x if the slope between points x negative 2 and negative 13, 6 is equal to negative 4/9. So for this, we're going to still use our same slope equation, but now we're just going to solve this for one of our variable terms instead. So let's go ahead and start off saying our slope of negative 4/9, and we're just going to set this equal to our standard slope equation here, where we're going to take 6 minus negative 2 for our y terms, and likewise on the bottom here we're going to take our two x terms, negative 13 minus x. The only difference here is we're plugging in that x instead of our actual value, and we know our slope, whereas normally we're trying to find our slope. But now we're going to solve this equation for our x in order to find our unknown x value here. So to solve this, we can multiply both sides by negative 13 minus x to get that term out of the denominator there. Which I'm going to just distribute everything in my next step here. So we'll get positive 13 times 4/9, because our two negatives will cancel out with one another. And we're going to add an x times a 4/9, because again, my two negatives here, negative x, negative 4/9, are going to cancel out with one another. And this is going to be equal to 6 minus negative 2, which is 6 plus 2. So now let's rewrite this over on the up top here. We'll have 13 times 4/9 plus x times 4/9 as equal to 6 minus 2, which is 8. Or 6 plus 2, which is 8. So now if I want to get rid of these ninths, I'm just going to multiply everything by 9 here to make this a little more easy for us to solve. So we'll have 13 times 4 plus 4x is equal to 9 times 8, which is 72. So now we'll have 52 plus 4x is equal to 72. And when we subtract 52 from both sides, we'll get 4x is equal to 20. Then we'll divide everything by our 4 and have x is equal to 5. So our original point here was in fact 5, negative 2, which when this point is paired with this point, they will result in that slope of negative 4/9.